For watching my lecture. Today I am talk about moment of inertia for different shape of an object. Now our duty is to find out of the moment of inertia in case of the different shape of the object. So today I talk type 1. In case of uniform rod and a rotational axis passes through the side and perpendicular on the length of an object. Here we can see the diagram. Suppose this is the uniform rod, this is uniform rod, this is uniform rod. Mass of this rod is m. Suppose m is a mass of the rod. Okay. L is the length. L is length of the object. Suppose the length is, this is the length. Length is L. Now, our first duty is to find out the very small thin part. Suppose the length is L. L is the total length of the object. If we think about very small section, the small section is length is very small, the very small length is dx. Now our duty is to find out the mass of this part. Okay, if we write this equation by this way, in case of the L length, the total mass of the object is m. In case of the 1 unit of the length, the mass will be m divided L. This is the unitary method. With the help of the unitary method, we find out the mass of the very small length. Okay. Now we calculate this by this way. Suppose in case of the length, the total mass of the object is m. In case of the 1 unit, সুতরাং if the length is 1 unit, then the total mass of the object will be m divided L. So in case of very small length dx, so the mass of this small length will be m divided L into dx. So we can represent this small mass by this way, dm. Dm represent the very small mass, that behavior as like a point mass. Okay, m divided L dx. Now our duty is to find out the moment of inertia of this very small particle. Okay, as already we find out the very small mass is dm, so we find out more of the moment of inertia in case of this part, dm, mass of the object. Let we the distance, perpendicular distance from this mass dm is x. Okay, so in our previous lecture we learned the equation of the moment of inertia. Suppose if this is the point mass m, and if this is the perpendicular distance from the rotational axis, suppose this is the rotational axis, and if this is the perpendicular distance r, and this is the x prime rotational axis, then if this object rotate around this axis, then we find out moment of inertia I is equal to m r square. Now we use this equation for find out moment of inertia for a very small length dx, and mass of this length dx is dm. So we can write moment of inertia is very small, di is equal to why we write di, because this small mass dm, the moment of inertia will be very small. So because of that reason we write very small moment of inertia with the help of the symbol is di. Di actually represent very small amount of things, some things. So at first we write mass, very small of mass dm, and the perpendicular distance between the rotational axis. As the rotational axis is x prime is the rotational axis. Okay, so we can write x square. So our duty is to put the value of dm. Already we find out the value of dm is equal to m divided l into dx. So we put the value here, m divided l into dx into x square. So we can write this equation by way m divided l x square into dx. So this is the equation. This equation represent the moment of inertia for a small amount of mass is dm. Okay, for a small amount of mass dm, the equation of the moment of inertia di is equal to m divided l x square into dx. But our duty is to find out the moment of inertia in case of the total object. Total object is lth length of the object. In case of finding out the total moment of inertia of this length L object, then our duty is to summation. Another name of the summation is integration. So after applying integration method, then we can find out the moment of inertia of the whole object. Okay, now we integrate equation 1. If we integrate equation 1 with a special range of the limit, then we find out the total moment of inertia of the object. Okay, so at first, before integrating the equation 1, at first we must have to set the moment of set the limit. So as we represent the length of the object is x, because dx represent the very small amount of length. Dx means very small amount of length. Okay, so we denoted length by x. So when now our duty is to find out the limit. If the length of the object is 0, that means there is no length, that means there is no existence of the object. So because of that reason, we denoted moment of inertia by I, so moment of inertia will be 0. Okay, this is our lower limit. When we denoted by length x exactly equal to L, that means this is represent the total object or the whole object. That length is L. Already we taken the uniform rod, the length of the uniform rod is L. So our duty is to find out the moment of inertia. For total length we represent moment of inertia I, so this moment of inertia will be total moment of inertia. So this notation is very important. So here we can see this is the lower limit and this is the higher limit, and this is also lower limit and this is also higher limit. With this limit, if we integrate equation 1, then we find out the total moment of inertia. So we integrate equation di both the side, m divided L di is equal to integration sign m divided L x square dx. So this is the integration. Now we integrate both the side. Now we put the value. Here we can see after d here has I, so the limit of I put here, and lower limit, this lower limit of I is 0, so this is the lower limit region and this is the upper limit region. The highest limit always we put the upper side of the integration sign, and as here we can see after d here has x, so x is the limit of x will be put this integration sign. The lower limit of x is 0 and upper limit is L. Within this limit, if we integrate this equation, that we get the total moment of inertia. Now our duty is to integrate this equation perfectly. We know the integration according to the equation of the integration rules, di integration is I. So we can write here I. After completing the integration, we write the third bracket. This is the third bracket. Why we write here? Because the integration of dx is x. The integration of dy will be y. So integration of di will be I. Di integration will be I. Okay. This is the law. So we can write I. The integration of di will be I. So because of that reason we write I. After completing integration we use third bracket. So we put lower limit here and upper limit here. Okay. Now we integrate this side. Here we see here integration will be with respect to x. So m divided L will be constant, and constant cannot be integrated. Okay, so we write here ml cannot be integrated because we integrate with the x-axis, with the help of the x-axis. So here we can say the power of x is 2. So the rules of the integration, we increase the power 1, that means 3, and divide the power 3. So after completing the integration we write third bracket and put lower limit 0 and upper limit L. Okay. If we put the limit, then we can write, at first we put the upper limit. We replace I by putting the value of the upper limit I. Then we use minus sign, then we replace I with the lower limit 0. Okay. And m divided L, 3 is a constant, so 3 comes out, and here only has x. At first we put the upper limit, x replaced by L. This is the law. And use cube, use minus sign, and x represented by lower limit 0. Okay. So I is equal to m divided 3 L into L cube. If we complete this equation, we get moment of inertia m L square divided 3. So my dear students, this is the equation for find out the moment of inertia in case of the uniform rod and if the rotational axis passes through the side of the object. Okay. Now we discuss again. Suppose this is the uniform rod, the length of the uniform rod is L and mass of the uniform rod is M. So our duty is to find out the very small part. The length of this small part is dx. This is the small part, a small section, and the mass of the small section is dm, and the distance between the rotational axis and this small mass is x. So we can write moment of inertia is very small of this section. di is equal to dm into square, x square. So this is the equation. Where we get this equation? This equation gives. From this equation we can write this equation. So our duty is put the value of dm. How we can find out the value of dm? At first we use the unitary method. This is our unitary method process. Okay. As the length of the object is L, total length, and total length mass is m. For in case of the 1 unit of the length, the mass will be m divided L. In case of the very small amount of the length dx, the mass will be m divided L into dx. And this is the represent of gm. This is very small amount of the mass. So after putting the value of gm, we get this equation, and if we rearrange this equation, that we get the new equation I1, and this is our final equation. This equation is our final equation. Now our duty is to find out the moment of inertia of the total length of the object. Okay, so we use here integration method. After applying integration both the side, we get the total moment of inertia. Before integrating equation 1, at first we have to set the limit, lower limit and upper limit. Within this limit, if we integrate this equation, then we get total moment of inertia. Suppose as we denoted the length of the very small part dx, so x represent the length of the object. So when the length of the object is x, the moment of inertia will be 0. Why? Because x means length. If x value of x is 0, that means there is no existence of an object. That means there is no object, so there is no moment of inertia. Because of that reason, I is equal to 0. And if x represent exactly L, that means x represent the total length of the object. So in these cases, the moment of inertia of the total object will be I. Why we write I equal to I represent the moment of inertia, and this I represent the total amount of the moment of inertia. Okay, now after putting the value of the limit and to complete the moment equation, or complete the calculation, and then we get the equation I is equal to ml square divided 3. I think that all of you know the basics rules of integration. If you fail to understand the basics rules of integration, then at first we practice integration section. Then after practicing the basics rules of the integration, then we comes here, and I think that all of you clearly understand. My dear student, I think all of you clearly understand. If you felt any kind of the section, then please write your comment on the comment section. I am try to repeat this part again. Okay, thanks to all. Take care.